Hey, what's up, guys? Today we're going to through the three basic gates, which is the AND, the OR, the NOT gate, the three basic gates. So we're going to demonstrate about them, and we're gonna do like a lecture, a little bit explain, and I'm going to build like a circuit about the gates and how you solve them. And actually, I'm going to do about I'm going to explain the truth table and how you solve them. All right. So we're going to see what's the input for the gate and what's the output for the AND gate and the OR gate and then the AND gate. All right. Stuck with me for a little bit, you will get it. But remember, before we do these, subscribe and hit the little button for upcoming videos for notification, and give me a thumbs up. And if you feel not comfortable what I did, put it down there in the comment, and I'm going through each question. All right, let's do it. So the first gate, I'm going to explain the three basic gates. In another video, I'm going to explain the rest of them. But for this episode, I'm going to explain the three basic gates and how they work and what's the input and the output. And actually, I'm going to talk about and demonstrate about the truth table. Or the first gate, it's the AND gate. That's the AND gate. That's the name for it. That's the symbol. That's the AND. Alright, and that's the AND gate, and how you can see actually it has like two input and one output. So actually, if you put, like, for example, 0 1, the output will be 0. If you change it, like, for example, 1 0, the output will be also 0. Alright, if you put, for example, 1 1, like positive and positive, 1 1 for the input, the output will be 1, so it will turn positive. Alright, let's do, for example, here we're going to do A and B, the input. So if I put the A and B in here, what's the output? The output also will be like this: A point B. That's the output for it. That's the AND gate. The AND gate, like that, it works. And the chip for these gates, it's 7408. That's the chip for the AND gate. The chip, it has like a legs in there. They put it on the circuit board. It has that's the name for it, 7408. That's for the AND gate. And also the truth table. So I'm going to provide the truth table for it. It's like this. A, B, out, put. A and B in the output. For example, if we put 0 0 for the AND gate, 0 0, what's the output? As I told you, will be 0 for the AND gate. All right. So like this. And what if we do like 1 and 0 for the input? So the output, like if you do like 0 and 1, so the output will be what? 0 and 1 will be 0 for this. 0 and 1 will be 0. Alright, so I'm gonna put the PDF down there on the category for the video. I'm going to put the PDF, how we practice about these. You read the description for it. Hopefully you will get it. For example, if we put like in here, as I told you, 1 0, 1 0. So the output will be 0 for it. If we put like 1 and 1 1 here, so the output will be 1 and 1, the output will be 1. I'm sorry, it will be 1, sorry, not 0, the output will be 1. It's upright, it's become like positive to it works like it's positive right now, so it's the input is positive, output is positive, 1 1, like the output is 1. For example, if we put the A and B, the output will be A point B, A times B. Actually, that's the truth table. That is the truth table for it, and that is the name for the chip. That's the name for the chip. 7408. It's the name for the chip. Oh, sorry. It's the name for the chip. It's basically like this. I don't know how to draw it, but I get you the 7408. I get you the name for the chip. That's a chip for the AND gate. That's a chip for the AND gate. So 7408. So I'm just basically give you the basic things and how you solve them, and that's also the truth table for it. So if we have 0 0, the input 0 0, the output will be 0. If we have like 0 1, the 0 1, the output will be 0. If we have like 1 0, the output will be 0. If we have like the input 1 1, the output will be 1. And we also, that's for the AND gate. We also have the, sorry, I got the lid. Actually, we have the other gate, the OR gate. It's the opposite side, What's the opposite side of this? I'm going to actually explain it in here. And that's for the last video. I'm going to actually explain about the OR gate. OR gate is like this. Oh, sorry. I draw it wrong. It's like this. That's the OR gate. That's the OR gate. And this is 74, 30, 35. This, if we put A and B. Okay, that's the OR gate. For example, if we put in this gate, as I told you, it's the opposite side of this. It's the opposite side. If we put like 0, 0, this will be like 0. If we put like 1, 1, this will be like 1. Like we put 0, 1, this will be 1, 1, 0. This will be, I'm sorry, 1, 0, this will be 1, sorry. And then 1 0, there will be 1, and then 1 1. I did 1 1. Okay, 1 0 0 1. There will be like 0 1 1 1. That's the input. If we have like, for example, the A and B input, the output will be A plus B. A plus B for the input, and the truth table for it is like this. we have like 0, 0, 0 in A, 0 in B, the output will be 0. As I told you, 0, 0, the output will be 0. If we put like 0, 1, the output will be 1. It's upgrade the, it's plus, because it's, look, 0 plus 1, it's 1. 1 plus 0 is 0. And here, in this one, it's 0, it's times, see? It's A times B. This is like a multiply. If you put like 0 times 1, 0. Because anything times 0, 0. Always keep it in your mind. Anything times 0, 0. That's why it's multiplying. See, A times B, it will give me like the A times B. But if you have like 0 times 1 will be 1, and so 0. If we have like 1 times 0, 0. Because anything times 0 is 0. See here, the last one, 1 times 1 is 1. Anything times 0, 0. Anything times 1 is 1. Alright, and this one is plus. That's why the OR gate, it's operate the opposite side, because it's different for multiplying, for like divisions. See, this is positive, the plus. See, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0, it's 1. 1 plus 1, it's 1, which is in digital, and like a binary. 1 plus 1 is 1. Alright, I'm going to explain in another video. I'm going to post another video, maybe another day, and how you can convert the number. How you convert the number from like from 1, 2, 3, 4, 5 to 0, 1, 0, 1, 0. For a computer brain, only understand zeros and 1. In human brain, always it's like you always understand like 1, 2, 3, 4, 5, 6. For example, your number 313, 586, whatever your phone number. But the computer always like it needs zeros and ones. It converts. It has like converter on the keyboard. Converts. If you put 7, it's gonna be the 7. Actually, it's 1, 1, 1, 0. The 7. The 8, 0, 0, 0, 1. And the 9, it's 1, 0, 0, 1. That's how you operate it. In the 10, it's 0, 1, 0, 1. That's the 10th. I'll explain to you another day how you can convert from numbers to digits, zeros, 1, like from numbers to the binary numbers. And actually, I'm going to do another videos for that, how you convert numbers to the binaries. For now, I'm going to explain the 3 basic gates and how they work, and why if you put zeros and the output is 1, if you put like 1, 0, it's output 0. It's all about these. It's all about the times. Remember these. Look in here. It's always like times, and this one is plus. That's why this one is times. If you do like 0 times 0, it's 0. 0 times 1, 0, because anything times 0 basically 0. 1 times 0, 0. 1 times 1, 1. Always keep it in your mind. Don't ask me again if you like, for example, why it's 1 plus 0 and 1 is 0. It's times. It's actually times, like this. Or if you want to put dot as they put in here, it's times. You multiplying the numbers. 1 times 1 is 1. 1 times 0 is 0. Anything times 0 is 0. And this one is plus. Actually, I'm going to make it clear for you. It's plus. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0, 1. 1 plus 1 is 1. That's why 1 plus 1. It's actually is 2, but in binary, in the computers and science, computer science, all these stuff, digitals. If you take like electronic classes, you'll understand these. I'm going to put another video how to convert from the numbers to the binaries, and stuck with me for a little bit. Another video I'll do it for it. Believe me, I will do it. Alright, so let's do, you understand these? That's called a truth table. That's truth table for this. That's actually how they operate, because if you put like in here 0 0, the output will be 0 anyway. If you put 0 1, 0 1, the output will be 1, because 1 plus 0 is 1. If you put 0 1, 1 plus 0 plus 1 is 1. So anything times 0 0, anything plus 0 plus 1 is 1. It's different. Actually, I'm going to put I believe the chip is 74. Let me check in here. 7435. I believe the chip 7435. Okay, 74. 7435. 7435. You know what? I'm going to explain that later, but I'm going to do. That's all you need. You don't need the number of it. That's all you need. The gates, the basic gates. That's the name of the gate. Right here. That's the name of the gate, the OR gate. And this is the name for this, the AND gate. That's the AND gate. That's the name for it, and that's the truth table. Alright, so I'm going to actually put the PDF down there, like on the categories. I'm going to put the PDF. If you want, just click on on my category and practice a little bit. I'm going to put like explanation, explain how they work and what's the chip name. And actually in the future I'm going to put more stuff. We're going to design chips, we're going to design like circuits. How about these? Actually another maybe another video after I'm going to do the binary codes. After that binary codes, I'm going to do the how to design more like circuits about them. But right now I'm going to design circuit. Oh, I forget to show you the AND gate. Sorry. Forget to show you the AND gate. It's the three gates, the three basic gates. It's the OR, the AND, the OR, the NOT gate. So hopefully you got these. I'm going to erase them. That's a name for it. That's the AND gate. That's a truth table. How they work: if you put like here 0, the output will be 1. If you put 1, the output will be 0. That's how it's converted. If the A over a line, if the line over the A, so that's mean converts. It's this little circle in here. That's actually the converter. If it's actually 0, it converts, comes in, out, converts from 0 to 1, from 1 to 0, it's converts. That's why they converts. That's actually the converter. The converter, this one converts from 0 to 1, from 1 to 0, converts. That's actually the NAND gate. That's actually use it, for example, if you have 1 1 0 1 0 1. If you wanna convert these, to the real numbers, you add 1, you convert these, that will be like this. You put 0 0 1 0 1 0 plus 1. 0 plus 1, it's 1. 1 plus 0, that will be 1. The 0 plus 1, 0. 1 plus 0 is 1. 0 0. That's how you convert them between the numbers, because it converts. If it's, for example, why I did this method is converter. So see here, if it's 1 in here, the output will be 0. If it's 1, 0. If it's 0, 1. If it's 1, 0. If it's 0, 1. 1, 0. Converts from 1s to 0. 0s, 1, 1, 0, 0, 1. I'm going to do more detail of this next videos. Hopefully next video I'm going to do the design circuits and how they operate, how they works. I'm going to do like a bake circuit. Alright, and let's do the truth table. That's the truth. That's a truth table. If you put like 0, the output will be 1, because it converts. And converter in here, this converter, if you have 1, this will be 0. If you have like here A, the output will be A, converts, always. That's converter. That's the NAND gate. Alright, so we covered the AND gate, the OR gate, the NAND gate. Hopefully you get these. But right now, let's design a circuit. Let's design. Let's see what's the output in here. I just draw this again in here. Let's do here, if we have, that's the plus, as I told you, times, plus. Alright, let's do here. If we have the A, if we have like A and B and C, here we have the A and B, here will be the A and B, what's the output will be? As I told you before, A times B. A times B. That's the output of this. And this output, it's B. B going here. That's the B in here. B, and this is what? C. See, the output will be B times C. So B times A times B and B times C. The output in here will be A times B plus. Why I'm going to put the plus? Because of this gate. B times C. That's the output for it. That's the output. For example, if you want to design like a zeros or one, let's do here 0, 1, 1 times plus. I just put here the letters to represent the input and the output, and then here I'm going to put 0, 1, 1. 0, 1, 1. Let's see what's the output for it. I put here 0 and 1. As I told you in the AND gate, 0 times 1 is 0. Because here's 0 and 1, this will be 0. As I told you, times, this is times, that's why I put the 0. 1 times 0, 0 times 1 will be 0. And this one here, this one will come down. That's the 1 will come down here to here. So in here we have 1, and this one we have 1. So 1 times 1, the output will be 1. So in this one will be 1 and 0. As I told you, the OR gate is 0 plus 1. The output will be 1 because it's plus. You see the positive sign? That's the positive sign. That's the plus. And here's the multiply, the times. See the dot? So here's 0 plus 1 is 1. That's a positive we have. That's a design, that's a circuit. That's how we design it. But next time, that's I'm going to do like, it's not physically. I'm going to do like Chair explain, but next time I'll design it like by the circuit and see what's like the input, how the lights operate. And let's design the different circuits. I'm going to put the converter between these. I'm going to put the circuit right now. Right here, I'm going to put the circuit, and I'm going to put the inverter and see how they converts between the numbers and digits. And let's go. Let's try. Let's erase this one. Right, let's design. Right now we have this. The converter. That's a converts between, like, if it's zeros become 1, if it's 1 become zeros. Let's see what's gonna happen. Let's see what's gonna happen with the converter. and here I did not put the converter, and I put like 2 AND, 1 OR, and I put here I changed the gate, and let's see what's gonna happen. Here's we have a plus times plus, and the converter. Let's see here, we have A, B, C. Here's we have A, and this one, it's B converts. B the line for it. That's the line for it, that's me converts. It's already converts between this. Here's a B, and here's a B converts. See what's the difference? There's a B, and the B converts. And this line, it doesn't convert, it's come from here. It does not touch the converter. It will be B, and this one will be C. So B plus C will be B plus C, and this one will be A times B converts. Why I put the line on tab? Why? Because it's converts. See the converter? It's converts. If it's B, it's gonna be B converter. If it's 0, will be 1. If it's 1, will be 0. This opposite is upright. So in here we have A times B converts. We have B times T plus C. So in this one, it will be A plus B converter can put the parentheses plus B plus C. See the difference? It's converts. See this one? It's converts. We have A, and that's the output. That is the output for this, for A, B, C. That's why we put the converter. Let's do now the digits, zeros and ones. Let's see what's gonna happen. Plus, let's put 1, 0, 1. I'm going to put 1, 0, 1. You pick any number you want to see how they operate. Actually, so in here there will be 1, and this one in here is 0 converts. As I told you, the converter, this one, if it's 0, it will become 1, and this one in here, it will become 1 because it converts. Without the converter, it will be 0, but the converter in here, if it's 0, become 1. And this line here, it's connected to the 0. This is 0. 0 will be here, and this one will be here. And this one is going to be like 0 plus 1, it's 1. As I told you, this is a positive here, positive sign. 0 plus 1 is 1. And this one here is the AND gate times 1 times 1 is 1. Alright, and here we have the converter, that's the OR gate. OR gate, that's the OR gate. This is the AND gate. That's the AND gate for this, and this is the OR gate. That's the OR gate, and this is the output. Output. That's the output for this. And these three the input. Input. This is the input. So when here I put 1, we get the outputs 1, 1. Here's be 1, 1. 1 plus 1 is 1. Positive. It become positive, the output is 1. And here we have, wait, is how we have 1 is 1. Hopefully you get these and you get how the gates operate. So I'm about to stop in this period. I'm about to stop in this time, at this time. So I cover up the 3 basic gates, the AND, the OR, the NAND gate, and how they works, and what is the truth table, and how to solve the truth table. And I designed a circuit for it. I put like A and B and C, the input, and I put like 0, 1, 1, and we saw like what's the output will be 1, and here will be a B with B times A times B plus B times C. That's how they operate. And I saw like we see like how they operate, and hopefully you get these. If you don't get it, I'm gonna put the PDF on the category, on my category. You can go check it out. Always click on the little arrow in there, and it will take you all the way to my category, and click on the PDF and learn more about them. If you don't even like understand how they works, put it down there in the comment. There's no problem. I'll be answering these questions maybe next week, because this week I'm busy and a little bit busy. So hopefully next week, as I told you, I'm going to do about the binary numbers, how the binary numbers, how the brain of the computer. I'm going to explain the brain of the computer, and the brain of the human, the brain of the human and the brain of the computer, how they works, and how they communicate each other, how they like the human understand like 1, 2, 3, 4, 5, 6, but the computer only understands 0, so 1, 0, 1, 0. I'm actually going to show you like and demonstrate and solve a problem, how they converts from 7, 8, 9, 10 to the 0, 1, 0, 1, 0. For example, 10, 0, 1, 0, 1 for 10. So you use like confusing how that's possible. 0, 1, 0, 1 for a 10. But I'm going to explain deeply the binary number, how they works, about the brain of the computer. Alright, I'm about to start in here. Today I cover up the basic 3 gates and how they works and how we design the circuit. So I'm going to design more and more circuit, and actually I'm going to do like physically lab on my disk next time, and I'm going to do like a big camera and do about these, and hopefully you understand these. And don't forget to subscribe my channel to do like more videos. I can post more videos and about the education, and I'm going to give you like tips and tricks how electrical engineering works and how they will operate, and you will see in the future how I'm gonna do that. And don't forget to support me, like subscribe and hit the little button for notification for upcoming videos, and give me a thumbs up, and put comment if you don't feel comfortable with these. I mean, basically I cover up like the basic stuff and very easy. I mean, in front of you can understand them. I went like through each thing, and actually I cover up how what's the name of the gate. See, the AND gate, OR gate, OR gate, positive times, how they operate, and how what's the input and what's the output for the gates. And hopefully see you next time. Don't forget subscribe and hit the little button for notification. Give me a thumbs up, and have a wonderful day. Thank you.